Hello everyone. So in this video we will discuss about the design of column, introduction and general terms we will discuss. So as we all know about column has a compression member. So in this building this is slab, then beam which is transfer the load to the column. So this is the column. So column which having a load of axial compression, uniaxial compression, biaxial compression like that. But most of the cases the load which is acting on the column is compression. So for the purpose we are designing as per the compression load, we design the column. So from the IS 456 page number 41, class 25.1.1, in the code book itself they defined column or stud. It is a compression member whose effective length is 3 times greater than the 3 times of least lateral dimension. In case the column dimension is 300 by 400. 300 by 400 means which is least dimension. So 300 is your least lateral dimension. So this dimension which is 3 times, so 3 into 300 which is 900. So it is greater than the effective length. 3 times of the least lateral dimension is greater than the 3 times which is effective length, we call it as effective length. If it is greater than the 3 times we call it as a column or stud. In case of if it is less than 3 times of least lateral dimension we call it as a pedestal. So both are compression members only, but we are comparing the effective length which is more than 3 times of least lateral dimension, we call it as a compression members. So this is the basic reference, basic definitions for the column. So you can refer also page number 41, IS 456 25.1.1. It is clearly mentioned in the IS 456. So next we will go to the classification of columns. So we having a 3 categories is there. First one is based on types of reinforcement. So how we have provided the reinforcement, main reinforcement, lateral ties. So it depends upon the types of reinforcement we can classify. First one, tied column. So in case of tied column, so simply this is the reinforcement, we provide the tied like that. This is the distribution reinforcement or lateral ties we call it as a. So this type of reinforcement we call it as a tied column. We providing the reinforcement. This is the column. We provide the reinforcement like that. We said call it tied column. Next one is spiral column, means this is the column which provide, this is the main reinforcement. We providing the lateral ties we call it as a spiral. So this is the spiral column. The third one, composite. Composite nothing but the concrete also there, and as well as the I section. When you see from the top it will look like a I. When see into the column we injecting in the I section and as well as the reinforcement. Then we are pouring the concrete, we call it as a composite column. So combination of steel, I section and as well as the concrete we call it as a composite column. So these are the 3 columns which is under types of reinforcement. Second, based on the loading, how the loading is acting on the column, we classified as a 3. First one is axially loaded column. Axially is nothing but the column is there. Load is acting exactly center of the column. So load is transferred exactly center point, gravity, center of gravity. So it is loaded axially. So that's why we call this a axially loaded column. Where second one, column with uniaxial eccentric loading is nothing but any axis, either x-axis or y-axis. This is the center point. The load is acting from the away from the center point. Away from the center point we call this a eccentric. That eccentric loading we call as a uniaxial, any one axis. Either it may be a x-axis, it may be a y-axis. So column with uniaxial, we have to design uniaxial also. Then column with biaxial means both the, when we see from the top, column top, this is the x-axis, this is the y-axis, x-axis, y-axis. The moment will be at both the side. The point will be, loading will be here also and as well as the here also. So both the axis, the point load will be acting both the axes away from the center. That is the important, that is the biaxial eccentric. So let me see in the building, there is a series of column is there. So these are the column, exactly we call it as a axially loaded column. So this one we call it as a column with uniaxial bending, because of 3 edges are tied, remaining 1 edge is free, so that edges will be called as a uniaxial. Whereas corner column we call it as a column with biaxial, because 2 edges only attached, supported, another remaining 2. So classification, third classifications based on slenderness ratio. So depends upon the length, effective length divided by least lateral dimension. So this is the column, this is the plan view. So this support we call as a L. So here this is B, this is D. The L by D ratio which is less than 12. L by D is less than 12, we call it as a short column. There is a no deflection, no buckling is acting, so that's why we call it as a short column. In case of if it is greater than 12, greater than 12 means we call it as a long column, which is referred here IS 456 25.1.2. so you can refer that. So if it is greater than 12 means the column will be buckled like that. So more than 12 we call it as a long column, less than 12 we call it as a short column. So we have to, condition will be vary for the short column and as well as the long column. So let's see in the deep manner. So next we will see the general terms used in the design of columns, which is mentioned in IS 456 page number 42, everything related to the design of column. So these are the terms we have to know before going to start the design of columns. So first one is unsupported length. In case of it is a vertical member, where is the floor to floor between, there is a clear distance is there. This distance we call it as a L. So unsupported length. So that unsupported length which is mentioned in 25 class 25.1.3, everything mentioned in the page number 42. So clear distance between end restraint we call it as a unsupported length. That is the definitions. Then next is we referred slenderness ratio. That slenderness ratio also having a certain limit is there. That limit is mentioned in 25.3 class. So unsupported length, that is unsupported length, it should not greater than 60 times of least lateral dimension. In case of the dimension is 300 into 400, this 300 which is should not greater than the 60 times of 300. So that is the slenderness limit, we have to follow that limit also. Then third one, minimum eccentricity. Even though it is having a load is considered, this is axial load, due to the construction difficulties, the execution problem, there is a problem arise, the load transfer at the center point. That's why we always check to the minimum eccentricity. That's why even if you are the load acting on the point away from the center point, we can easily manage. In case of if not consider the E minimum, the chances to collapse that column. So that's why we have to always check for minimum eccentricity. Eccentricity is nothing but the point where the transfer away from the center axis, away from the center, this is the center point. In case of the distance is away from the center point, there is a deviation is there. That deviation is have to be checked. The formula is there, L by 500 plus 3 by D 30. It should not be less than 20. So always greater than the 20, we have to check E minimum. If it is greater than 20, no problem. We have to check this condition. That is the minimum eccentricity. Next, effective length depends upon the support between the column. We have to mention effective length. This is the unsupported length. This is the effective length, which is mentioned in Annex E from the IS 456 page number 94, table number 28. Different types of support is there. Effective length of compression member, page number 94, table number 28. So here mentioned the different support is there. So first one is effectively held in position, restrained against rotation in both ends. So both ends are fixed. The one end is pinned, another end is fixed. Third one is both ends are not restrained, both ends are pinned only. Then fourth condition is one end fixed, another end is free. Then fifth one end is fixed, another end is also some deflection is there, so partially restrained. So sixth one also like that, pinned joint in the one support and the remaining is free. Then this one is the effectively restrained against rotation at one end, another end is not restrained. So depends upon the support we can calculate the effective length different conditions for the here 0.5 L, 0.7 L, 1 L, 1 L, there is a no. Then sixth one is 2L, then 2L. So this is the condition we have to taken for the effective length for different support. So length between points of where zero bending moment, the both ends are we consider, but where it is bending moment is zero, we consider that length we call as a effective length. So we have to refer the table before going to the design of columns. That's why in case of we are choosing the fixed one, both ends are fixed, means we have to check the conditions. What's the effective length? Then fifth one, braced columns and unbraced columns. Unbraced columns is nothing but we have to consider the vertical load and as well as the horizontal load. So this is the two column is there. In case of consider the vertical load and as well as the horizontal load, because of the column will be deflected sideways also. We have to consider sideways, consider means that column is unbraced column. In case of the both end, again it is restrained by the bracing, so we call it as a braced column. Side sway is insignificant. It is the example of water tank. So overhead water tank, this is the water can, we provided the column is arrested by the bracing. That bracing we called as a braced column. This kind of column we mentioned as a braced column. So it is arresting the lateral loads also. This is the technical terms we have to know before going to the design of columns. Unsupported length, slenderness limits, minimum eccentricity, effective length, braced column, unbraced column. Design requirements, IS 456 specifications for the design requirements of the column. So first of all, this is your column plan view, cut section. In case of you are providing the reinforcement here, this is your concrete, this is reinforcement. The reinforcement area should be minimum 0.8%, maximum should not go away from the 6%. It should be in the range of minimum is 0.8, maximum is 6%. This is the condition for the column. So overall 100%, the reinforcement should be these conditions. So in case of if it is rectangle, we have to use minimum 4 number of reinforcement. In case of circular, we have to use at least 6 number of reinforcement. That is the conditions. The third one, diameter of the bars, we have to use at least 12 mm diabar. Should not use less than 12 mm bar, we have to use more than 12 mm bar. Then lateral ties, in case of this is your column reinforcement. So this is your main reinforcement. So this one is, we call it as a lateral ties. So lateral ties is nothing but distribution reinforcement. That distribution reinforcement nothing but we have to use at least 1/4 of main diameter, should not less than, or you should not use minimum should not use less than 5 mm. In case of if you are using 16 mm diabar as main bar divided by 4, the answer is 4 mm. But our condition is should not use less than 5 mm. So we have to adopt 8 mm, 6 mm or 8 mm for the lateral reinforcement. That is the conditions. Next, pitch. Pitch is the distance between the space between lateral ties. That name we call it as a pitch. So as per the IS 456 requirement, page number 49 mentioned clearly, among the four conditions we have to, which is less, we have to adopt as a pitch. So first one is least lateral dimension. So in case of this is your 400, this is 450 means which is 400 here. That is the first one. Second one is 16 times of smaller main reinforcement. This is the 4 reinforcement. In case of if you are using 16 mm, so 16 into 16, 256 mm. 48 times of diameter of transverse reinforcement. So this is lateral ties, is we call it as a transverse reinforcement. 48 into 6. Okay. Another term is 300 mm. So among the four, which is very less, 6 into 4, 240, 288 something. So among these four, 256 is your very minimum. So pitch distance is 256 mm. We have to choose. So this is the conditions, IS 456 specifications for the design of column. We have to keep it in mind while designing the column. You have to everything we have to adapt as per the IS 456. Case of pitch for the helical reinforcement. The helical reinforcement, this is the column, this is the main reinforcement, this is the lateral ties. The lateral ties, if it is in spiral, the spiral of here to here, the distance is, we have to maintain minimum 25 mm, maximum should not exceed 75 mm. The range between 25 to 75 you have to maintain for the helical reinforcement pitch distance. In case of if you are using along the periphery, we are using the reinforcement here, the spacing between one main reinforcement to another main reinforcement should not exceed 300 mm. Along the periphery only we have to consider, that is should not exceed 300 mm. Then following assumption we have to taken care while designing this column, which is mentioned in page number 70, your IS 456. The first one is maximum compression strain in concrete in axial. That time we have to maintain assume 0.002. In case of axial compression and bending, when there is no tension is acting, at that time we have to maintain 0.0035 minus 0.75 times of least strain of least lateral dimensions. So that is the least compression strain. So epsilon naught here, strain is nothing but the output. So maximum compression for the axial compression plus along with bending, we have to maintain this formula. Then in case of if we are finding the design stress of steel, we have to adopt 0.87 times of Fy tensile stress. So when minimum eccentricity should not exceed 0.05 times of D. D is nothing but the least lateral dimension. B, this is your column. So in your column, B and D is we mentioned if it is a rectangular column. So here among these two dimensions, which is least lateral, so that is we have to consider it here 0.05 times of capital D. So it should not exceed the minimum eccentricity value. So this is the formula which is going to adopt for the calculation of ultimate load. Either we are using this formula or this formula. PU equal to 0.4 FCK AC plus 0.67 FI AS, or 0.4 FCK AG plus 0.67 FI minus 0.4 FCK into AS. So this is your column. So this is your reinforcement. So this portion we call it as the AC, area of concrete. This one we call it as the area of steel. The overall portion we call it as the AG, gross area. So total of concrete plus steel we call it as a gross area. In case of they provided the gross area, you have to apply this formula. In case of they provided the area of concrete is separate, area of steel is separate, we have to use this formula. So either you can use both of them. Among the both of them we can utilize the formula, then you have to find out the design load. After that we substitute the bending moment formula, then you have to find the reinforcement.